All right, good evening, everyone. Welcome to the October meeting for the North Texas AMS NWA chapter. I'm Steve. All our officers are here, and we're glad to all have you here in the room and here online for it. So, oops, I left a piece of paper on the desk. So just all right. Now we've all had that very nice awkward pause. I just want to go ahead and introduce our speaker, Greg Waller. He is the Service Coordination Hydrologist at the National Weather Service River Forecast Center here in Fort Worth. He got his degrees at Texas A&M University. After a couple of years in the private sector, he joined the Weather Service. He's been at multiple offices, Columbus, Georgia, Houston, Galveston, San Angelo, and since 2000, he's been here at Fort Worth. He's held multiple positions within the RFC, and now he's up there in management, making sure everything runs smoothly in the office. And I have fun coordinating with him over the years over precipitation products. So without further ado, here's Greg Waller.
All right, thank you, Steve. Best way to explain it, Aggie that got hooked into the science of meteorology, age of 13, 1983, and I'm a Houstonian, so most weather folks know exactly what that is. That's Hurricane Alicia. When I got to Texas A&M University, there were 4 of us, all from the Houston area, and now 3 of them are working in San Angelo. One is the MIC, one is the WCM, and one is their lead forecaster, and that's Amy Campbell, who is at Aldine Eisenhower, Mike Castillo, the new WCM, I think, who was from like Aldine, and then Patrick McCullough, who was at Nimitz, or not Nimitz, he was at Kingwood, and I was at McCullough. So it's amazing that one storm can catapult you into your career, all of us being 13 years of age. The best way I can explain it is I hate the cold weather. That's why you've seen Columbus, Georgia, Houston, Galveston, San Angelo, and Fort Worth on my resume. I'm as far north as I'm going to get in my career. I believe snow is a 4-letter word that begins with S, and I treat it as such. But since I came from the forecast realm and the tropical realm into the river forecast center realm for the last 22 years, I've zoned in on how much heavy rain, what's it going to do, how high is the water going to get. And in doing so, that's most of the weather service, hurricanes, tornadoes, storms, and the flooding aspect is that's also a problem. And one of the jokes that I've given, especially with a science officer in Austin, San Antonio, a lot of people don't seem to care about water until they're waist deep in it. And I said 99 out of 100. He goes more like 999 out of 1,000. There's a lot of people that just don't seem to pay attention to water until it's too late. So I've dedicated my job as coordination hydrologist. How can I get the message across? Heavy rain forecasting and then the resulting flooding from it. How I've adapted my message over the last year or two is I have to explain the so what. Okay. If I say it's going to rain 10 inches, so what? I literally gave a study. I said, if it rains 10 inches in Fort Worth, and I gave it to all the parents of my kids' class. And there was a lady, she's got a master's degree. So she's very educated. She goes, 10 inches is only about midway up my shin. I think I'd be all right. So at that point, I realized that giving a rainfall forecast isn't enough. It's this so what to the rainfall forecast. If I say the Trinity River is going to get to 38 feet, so what? 38 feet at Liberty, 38 feet at Dallas, 38 feet at, White Settlement, that area, those are different measurements. It's the so what. The best way to explain so what is flood inundation maps. We've gone through the process of trying to calculate volumes of water, but now we've got to get it into a hand that people can make an actionable decision. And the best way to do that is I need a map. I need to know where this water is going to be and where it's going. So if we want to go and advance to the next slide. I am the service coordination hydrologist. I like saying I'm the equivalent, but I cannot hold a candle to Mark Fox, the WCM, or now Jennifer Dunn, the WCM, the warning coordination meteorologist. They are much more into the local aspect of the local governors, local emergency managers, local mayors and county judges, that type of thing. I am the outreach component, but it is more at a federal level, at a statewide level, and a regional level. But I am the RFC version of the warning coordination meteorologist. Like Steve said, class of '92 out of Texas A&M University. My career is in the South, but however, I maintain my sports allegiance both to Texas A&M and to all the Houston teams, and I am not too pleased with the result of ALDS Game 1 that just ended recently. So that is a picture of me and my son. He has got me into Scouts by default, and that would be us climbing Guadalupe Peak with the A&M flag. And then last summer, we were in Minnesota at the northern tier, the lakes between Canada and Minnesota. And that is us standing on one of the monument boundaries, with me being in Canada at the time and him being on the US side, right on the US-Canadian border. So I've taken out a lot of other scout type pictures for this, because it's the AMS, it's not the Grant Waller celebrity tour, but I'm proud of that dude, and that's what keeps me going in this job, in this passion. Next slide. Why it's important. We started grabbing this information after Harvey, and this is a 5-year running total of flood-related fatalities by state. And you can see color-coded each one. Even before Harvey hit, we had the 2015 floods with all the flood emergencies, and then we had the 2016, the Memorial Day, and we had just flood after flood after flood, and then Harvey came in, and then after that, there's a lot of people that they said if there wasn't a Harvey, Imelda would be the storm everyone talked about, is how bad as Imelda was in Southeast Texas. But you can see that there is one state that leads the rest in flood-related fatalities, and if you take the second and third and combine them, they're not close. There's something about Texas. And so if you'll go to the next slide, and when we add another year to it, you'll see that there seems to be, conglomerated along I-35. We all know that Austin San Antonio calls themselves the flash flood alley due to the topography, the meteorology, that type of stuff. There's a large component in Houston, and that's from Harvey. But you can see, Dallas-Fort Worth area is also in it, all the way up in Norman. The stats have shown that if we can convince the old men in this group, like me, ages 30 to 60, to stop driving their dang trucks through high water, we could probably get rid of half of these numbers. That seems to be the demographic: vehicle related, male, and in the 30 to 60 time frame. Now, there are other cases, kids getting swept off. There was a case in Palestine where the family got flooded out of a home, of a creek, a flash flood. But seems to be a boundary, right along I-35 of flash flood and flood related fatalities. And so let's go through. This goes through 2019. So if you click and go forward to 20, you can see that 20 was a little dry, and we had maybe some tropical activity in the Carolinas. If you go to 21 though, Ida, the flash flooding in the Tennessee area, and then the massive flash flooding up in the New Jersey area. Texas, even in drought, we're still having flood related fatalities. But in the last year or two, the focus for flooding has really shifted out of Texas. Maybe that's good messaging, but I think more than anything else, it's just the fact that it hasn't been raining. And if you go to 2022, as of this morning, when it pops up, you'll see that Kentucky, the flash flooding that they had earlier this year, the catastrophic flooding in the eastern half of the state. But even in the middle of one of the most historic droughts we've had, top 2, top 3 droughts ever, we still have 3 flood-related fatalities in the state of Texas. So the message to get out there is to stop, take water seriously. Stop driving in it. Stop playing in it. Next slide. Our process that we try to get the message out is we try to gather all the meteorology information we can. Rain on the ground, but how do you do that? You can do that from multiple ways: rain gauges, radar, and satellite. But we also try to take into a forecast. Now, I know I'm old, but you would think the sciences would advance a little bit more than it is. When I joined the West Gulf River Forecast Center in 2000, if we used more than 6 hours of a quantitative precipitation forecast, not 30% chance of rain, it will rain 6 inches here in this time frame. If we used more than 6 hours, our forecast started going just haywire. We did not have the skill beyond 6 hours of meteorology. Another way to look at it is, when I joined the Weather Service in 94, they said that we're accurate to 3 days, and our day 4, day 5 forecast is kind of eh. Well, right now you could say that our forecast through 5 days is pretty good, and our day 6 is kind of eh. So we're extending the time window in meteorology slowly but surely. In our world here, we've extended that 6-hour window out to 24 hours. At 24 hours, there's a distinct marketing point where our forecasts, we have more false alarms, and we lose probability of detection. So, anything beyond 24 hours, I know it's going to rain, but let's not go on the amounts, because it starts hurting the river forecast process. So there's past rainfall, there's future rainfall. What is the soil like? The old soil moisture models, they were just, We started up from scratch, fresh every day. That's, if it's dry, the soils are going to act different than if it's been raining for a week straight. The soils are going to act different. So we have a continuous steady state model, Sacramento soil moisture model, that we run daily. So we know the soil moisture conditions going into an event. The big one where my job comes in as the coordination hydrologist would be lake releases. I love telling people that are not from the state of Texas, hey, how many natural lakes do we have in the state of Texas? They think of all the lakes across the state of Texas. Well, the answer is one, and it's not in my area. It's on the Texas-Louisiana border, Caddo Lake. Every other lake in the state of Texas, a human being decided, I want to put a lake here. What was it designed to do? What is it capable of doing? And what are your decision trees when the lake starts getting here? Because I need to know what you're releasing so I can put the forecast downstream. When all that goes out, we send it to the weather forecast office. It shows a single deterministic line. This summer, we're actually going on to ensembles to try to get that information out to get you a better grasp of it. But once the message gets out, if it's going to be high enough that it impacts a human being, we're going to try to issue a flood warning and get people to pay attention to it. This is not the flash flood alerts that'll be hitting your phones. The flash flooding is done by the weather forecast office. The river flooding, the riverine flooding would be done. The volume calculations are done from our office, but then we pass it to one of 14 offices in our service area. So if you go to the next slide, right off the bat, I am tired of hearing 500-year storm, 100-year storm, whatever. They actually, in 2016, they had a lady on the west side of Houston. She goes, I just don't understand. I've had 300-year storms in the last 2 years. There's something wrong. It's like, no, you don't understand statistics. Okay, but that can happen. But I grabbed these maps from Jeff Lindner, Harris County Flood Control after Harvey. Now, the map on the left would be the rainfall return period. And you can see that in purple, there were parts of Houston that had a 20,000 year, once in 20,000 year event. In that same area on the map on the right is the basin channel response. And some of those areas had 100 or even a 50-year return period. So it flooded, but it kind of was common flooding from historic rainfall. So was it a 20,000 year event, or was it a 50-year event, or was it a 100-year event? Because if it's a rain event, you got to say it's a 20,000 year event. But if it's a flood event, what is it? Humans, we have a finite amount. Scientists, we love this stuff, but the rest of the people that don't, live their lives for this don't understand, hey, the water's just high. So the National Weather Service, and I forbid anyone in my office when they're talking to the media or emergency managers, do not use a return frequency of anything. It's not a 100-year event. It's not a 1,000-year event. It's going to be minor flooding, moderate flooding, major flooding. It's a categorical level. So right off the bat, let's I don't want to say dumb it down, but let's slow this entire school of fish down to a common swimmer. And the best way to do that is to use Weather Service terminology and not return frequencies. Next slide. So when it comes to forecasting the Trinity, right off the bat, when I talk to some of the folks in the mountains, they go 1,500 feet change in elevation. I go, hey, dude, this is Texas. Okay, it's 1,500 feet from outside of Bridgeport till you get to the mouth in the Galveston Bay. That's a pretty good slope change, especially, up north and west of the Dallas-Fort Worth area. Know your reservoirs. Everyone's like, well, when it floods here and it floods there, I go, man, any rain that falls on the Dallas-Fort Worth area, it's got a different path than any rain that falls around, because to the north is a series of core lakes. To the west is a series of Tarrant regional lakes. To the south are some core lakes and some city lakes. So, the Dallas-Fort Worth area, know where your reservoirs are. Okay, I once counted up that it takes, I think, 10 lakes can make a release and affect the Trinity River at Dallas. So I better know what their operating schedule is and what their levels are and what their inflows are. Then you get just slightly downstream, you got Richland Chambers, you got Cedar Creek, you've got another whole trib of Levon and Ray Hubbard, you got 2 core lakes of Barbell. There's a whole lot of lakes involved there. And during big flood events, the Trinity River can take one full-time individual hours upon hours to do the iterations. This is after the rain has fallen, of how these lake releases are going to happen. The most interesting thing about it, though, is it has the 4th largest metropolitan area in the United States in the middle of it. So let's add a concrete jungle in the middle of all these reservoirs, in the middle of all this stuff, and let's see what happens. And hey, Greg, go ahead and predict the Trinity River to a 1/10 of a foot accuracy 5 days out. So next slide. What we talk about is minor, moderate, major. The best way to explain it is just because the river is out of its banks doesn't necessarily mean it's flooding. The terminology we use is minor flooding is if it has an impact to a human. Maybe it's a golf course, maybe it's a park, maybe it's a small secondary road. Once the river gets high enough that it starts inundating those roads and threatening buildings, we call that moderate flooding. Once there's water in those buildings and threatening major highways, that's major flooding. And obviously record flooding it's never been that high before. Who sets these levels? Well, your friendly service hydrologist at the National Weather Service offices. If you don't know who they are, You got, Dr. Amanda Schroeder is one, and Katie Landry down in Houston is the other. That's the entire Trinity River system. If you want to know what your criteria level or what your impacts are, 2 individuals right there to go to. If you're wondering what the impacts are, they populate them on the webpage. And if they're no longer accurate, then hey, get with them and let's make them more accurate. This is where flood inundation mapping can come into play. If we do simulations and all of a sudden it's like, hey, these areas are no longer impacted, a levee's gone up or something, maybe we can update our impact statements. The point is a lot of people are going to look at this page and say, I know at 28 feet this happens, and we've just forecast 28 feet. Let's hope those impact statements are accurate. And if they're not, go to Amanda Schroeder or Katie Landry Guyton. Next slide. So I got a nerd out here. I'm a sci-fi, especially from the 80s. This is, even though I love the new Dune, this is actually the old Dune from 1984. And the first step in avoiding a trap is knowing of its existence. What is the trap? The trap is communicating the science of what is the risk. The risk is your threat, heavy rain, and what is your vulnerability? There's the key. The vulnerability changes. Okay, the vulnerability changes every 10 years. Sometimes the vulnerability changes every year. Okay, so we know that each event is different because the risk changes from time to time, event to event. No 2 rain events are the same. No 2 flood events are the same. And we've changed the footprint underneath. So what I tell everyone, know everything about everything all the time. You're going to fail. That's going to happen. But know as much as you can, because information is your shield. Information will protect you. But your shields will eventually fail. Are you ready for that as well? Okay, there's the Flash TV series, the 4-step plan. Make a plan, follow the plan. When the plan goes off the rails, follow my judgment. That's what I hope, is that 99% of the time the plan stays good, but when we hit the large events, the Imeldas, the Harveys, the Dallas 14-inch rain event back in August that we predicted, okay, trust us when that goes south. Now, if you hit the next slide here, the problem is we know vulnerability. Dallas-Fort Worth just keeps growing and growing. I think at one point I read we were gaining 11,000 new people a month earlier this year. Okay, do those people know Texas hydrology and Texas meteorology? And if not, what is the footprint? What is the building changing landscape? But other thing that I can say now that we've been told we're allowed to say, if you hit the next one, is we also know the threat is increasing as well. Anthropogenic, climate change, the forecasts are it's going to get worse. And they say worse how? The way I explained it, our droughts are going to get droughtier, our floods are going to get floodier, and our heat is going to get heatier. We're going to have more extremes, okay? And that's the message that to be said. So you're going to have more heavy rain events in a higher vulnerability area. That means your risk is going up. Are we prepared for that? If you go to the next slide. To explain the footprint, I grabbed these images way back when, but this is the Dallas-Fort Worth area from 1979 to early 2000s. And you can see 79, when I lived in Mineral Wells before we moved down to the north side of Houston, I mean, so there were some lakes weren't even in existence. Ray Roberts up, north of Louisville didn't even exist. And now you look at it in 1989 and you start looking at the urban sprawl. Weatherford used to be the country. Weatherford, to the west is now a suburb. The sprawl goes out. Well, when you put concrete down, when you put a strip mall in, you increased runoff by 100% and much faster, and you've changed the soil moisture characteristics. So if you go to the next slide, and you can just see that, if you took a satellite view, there's just not a lot of green area in our population area. So you be prepared for the extreme hydrology to go along with the extreme rain, because we have increased our vulnerability in our footprint. Now, you want to go down to the next slide. Let's go Houston and Harvey. I just got back from Houston today, literally drove up from the Kemah area. It used to be that, Texas City, Lamarck, Galveston had some swampy area. And once you get to about Spring on the north side, you turned into the woodlands because it was woods. Now you're pretty much Houston from Huntsville to Galveston and pretty much, outside of Baytown all the way over to Katy. That area has exploded. It's a swampy area. They've turned it into a huge vulnerability footprint, just because of all the concrete and building that's going on. So they say, well, what about Harvey? What about Harvey? Okay, what about Harvey? I said, all right, go ahead. And I got an argument with a state climatologist, Dr. Nielsen Gammon, about this Texas Weather Conference. If you go to the next slide, it was not an unprecedented storm. I'm tired of hearing people say Harvey caught us off guard. It was unprecedented. Harvey was not unprecedented. Go to the next slide. There was a major hurricane that made landfall in the Northwest Gulf Coast, moved inland, moved up to about 30 degrees north latitude, sat for about 4 to 5 days and produced rainfall that the area had never seen and flooding that the area had never seen. That wasn't Harvey. Go ahead. That was Hurricane Alex in 2010. So don't tell me that it was an unprecedented event when I've worked 2 of them. I may be old, but I haven't, it's not that unprecedented if I've worked 2 in my career. And what Dr. Nielsen Gavin said is, yeah, but we can't find any others on record. I said, it doesn't matter. Harvey was not unprecedented because we had a blueprint. We know that this type of storm can exist. It has happened now twice in a 7-year period. And do we need to find a way to prepare for it again? What if it moves into the Austin, San Antonio area and sits for 4 days? What if it stays just outside of Corpus and sits for 4 days? So don't tell me that Harvey was an unprecedented storm. It had unprecedented impacts because it hit a vulnerable area. But I fear we're going to see another storm like that. So if you go to the next slide, just keep going here. Like I said, Alex 2010, the flooding that we saw over there, Amistad and Falcon are on the international border. They're 2 reservoirs that are operated, and there's a huge water treaty going on. They both filled and they both spilled. And no one remembers that happening in the history of those reservoirs. The flooding that was on the Mexico side, that was just, everything that you could see from space. It was just one big slow-moving lake. It just didn't get the notification in the United States because it happened in another country. But it was still in my area of responsibility, which is the Rio Grande. So, our staff, we've told them, we've worked Harveys before, and we need to prepare that in our staffing profile. So if you go next slide, do you know your watershed? Now, I had our GIS folks put this together way back when. Houston, the Fort Worth office put out a tweet earlier this year, and I'm going to go off on a little sidetrack here because from Houston, I've been told by a guy that grew up in the DFW area that works the Weather Service, who went to TCU. Y'all can maybe figure out who I am, but he goes, Wally, why is it all you Houstonians have this big thing about DFW? We don't even care that you exist. And I went, dude, I grew up in Houston my whole life. And to be honest with you, we just hate the Cowboys. We don't care that DFW exists either. And he goes, no, you don't understand. I understand. They put out something of this watershed. Do you know what happens when a raindrop hits the ground in the Dallas-Fort Worth metro area? If you'll go through the bullets on the left, or on the right, you'll see that if it's north or south or west, Dallas-Fort Worth is protected. Oops, go back there. Dallas-Fort Worth is protected. So if it falls in the Dallas-Fort Worth area, metro area, though, and it starts going down the Trinity River, there's nothing to stop it until it gets to Lake Livingston, which is a water supply reservoir. So, there's a lot of people like, oh, when you do this and you do that, I go, man, actually, any flooding in the Dallas-Fort Worth area, there's no way to stop it, control it, or contain it. Until it makes the curve and starts heading south. So with that, do you know your watershed? Do you know? We went to a meeting down in the Houston County, which is just north of Lake Livingston, and the locals really wanted to know why Tarrant Regional Water District was always flooding them out. We turned around and go, what? And they were equating every flood that came out was Richland Chambers releasing water, not realizing the 15 reservoirs that are on the Trinity River system, not realizing that anything that falls in our metro area is 100% runoff and moves down. And the best way I could explain it, I said, I worked with an old timer, and he said, the rule of thumb is if you see 2 inches of rain in Dallas, put out a minor flood forecast. And he stepped back, scratched his head, goes, no, it's now 1.5 inches. If you see 1.5 inches of rain in Dallas, put out a minor flood forecast, because that's how much buildup has been in and around the area. If you go next slide, I think this is where the glitch, go ahead and click through all this. We already went through all these. So this is a duplicate slide because I wanted to move it up. But when I jump into the meteorology, let's get into AMS, the American Meteorological Society. Let's talk about precipitation. We use a program called the Multi-Sensor Precipitation Estimator. We have a lot of acronyms. It's called MPE, but it combines radar, gauge, and satellite data. The better the gauge network, the better result. The better the radar coverage, the better result. The better satellite that goes up, the better result. The best part about it is satellite technology from just in the 2005, 2010 range was average at best. The new GOES-R satellite is superior. But more than anything else, it's the radar technology. I'm not bragging because he's in here in the room, but the ability from the National Severe Storms Lab to take a radar beam and have some return power come back, and the accuracy that it provides in both the aerial content and the amount of rainfall, especially when I get a good gauge network under it. It's called the gold standard of precipitation. Okay, because it's better than any field by itself. This combined satellite radar gauge field. The future of quantitative precipitation forecasting, ensemble models are the way to go. So we do an ensemble of that, but the humans are being taught when you're at blackjack at Vegas, you're counting cards, when is your moment of opportunity to really jump into it? I'd say 90 to 95% of the time, a blend of model is going to beat the human. So when does the human, when do they identify that 5 to 10%, and what are the events? I think example would be the Dallas flood back in August. Okay, our ensembles were hitting the area, but they were not hitting the amounts, and they sure as heck wasn't hitting the impacts. And we tried to jump on that as soon as possible. It seemed to catch a lot of people by surprise, but I do know that I briefed Governor Abbott and Chief Kidd, head of all the state emergency management, on Saturday before the Sunday night rain, said it's going to happen. I'm concerned with Dallas Fort Worth. This is a heavy rain event. So I know that we gave the state at least 24 to 48 hours of notice on these type of things. That's QPF. Use your best of the models, and then know when your opportunities are for the human influence to kick in. So next slide. The gauges in the area, in any given hour, the National Weather Service River Forecast Center, we're looking at 2,000 to 2,500 rain gauges reporting any hour. You can see that the Dallas Alert, Tarrant Regional Water District, USGS, there's a look good there. If you go down to the Colorado River, all the way down the Austin, San Antonio area, the Lower Colorado River Authority have so many gauges, you could almost walk, from the Galveston Bay area up to Austin and never touch the ground. I would love a gauge network that dense. But when the Trinity River starts going towards Crockett, towards Houston County and towards Madisonville and Centerville, our gauge network starts getting a little thin. We have to start really relying on the radar. There's no radar around there, or the satellites. So the gauge network, the better the performing gauges every hour, the better our product's going to be. Next slide. Our radar coverage, wish we could put radars everywhere, but radar beam shoots out at a 1/2 degree elevation. And so the further it gets away from the radar, the higher that beam is off the ground. There can be a whole lot of meteorology going on in the bottom 10,000 feet. And there's large sections of the Trinity River that we have what's called, radar gaps. Dallas Fort Worth, Sphinx is great. I mean, Sphinx is almost in the perfect position. It's 20 miles south. It can cover Dallas. It can cover Fort Worth. We get great radar coverage. We get a great rain gauge network. So we feel confident in the rain estimates in the Dallas Fort Worth area. But you asked me the rain estimates in Madisonville or Centerville, and I'm like, okay, we feel pretty good about those estimates. But it gives you an idea of radar coverage across the area. We've tried looking at CASA radars. We've tried looking at terminal Doppler radars. The time frame and the volume scans makes it just too difficult to get into our processing algorithm. So that is a flash flood type of tool, but not a river flood tool, not a precipitation estimate tool. Next slide. So what do? We sample it, okay? We've got a radar shooting at it. We're going to have another radar shoot. We got a multiple radars in some cases. We got gauges all over the place. We got a satellite shooting at it. We're going to have another satellite as long as people don't drop it on the launch pad or whatever. But the kicker is that compared to where we were in 2000, the technology has advanced tremendously, and our accuracy has advanced tremendously as well. We're going to see that raindrop when it starts falling. The next slide, we calculate all the raindrops together, and we come up with a very accurate volume of water above the ground. It's on a 4-kilometer grid called HRAP, Hydrologic Rainfall Analysis Project, that goes back in the way back when days. Well, right off the bat, some people need it a little finer. So some of the radars can provide a little bit finer data, but the calculations we use are on a 4-kilometer gridded scale. And it's the multi-sensor precipitation. We grab every radar, we grab all the gauges that come in, and we grab the satellite field. We start running it at the hour plus 15 minutes with our goal having everything human quality control, take out the bad gauges, save it at the hour plus 45 minutes. So hopefully by 12:45, you're seeing the end of the hour at 12 o'clock, the best radar product available, and it goes to the web and it goes to all of our customers. Again, it uses all of the fields available, gauges, radar, and satellite. Don't rely on just one. We have a lot of people, we got a radar there, so that should be good enough. No, man, I want more than radar. I want radar, gauges, satellite, and I want a human looking at it over and over and over again. Next slide. It helps with the Texas Mesonet, both in rain gauges and now soil moisture. And I've always said that when a Texan says anything good about something from Oklahoma, that's got to be pretty outstanding. The Oklahoma Mesonet is a superior system with superior spacing and superior data. Okay, and it really helps, the forecasters up there look at fine features that can help with thunderstorm development and rainfall. Texas Mesonet is trying to catch up to that. But on top of that, they're putting in soil moisture sensors. There's over 90 in the state of Texas alone, and we're trying to figure out how to get that soil moisture data into our soil moisture model. We've never had that before. So we're looking at Texas Mesonet, and oh yeah, you're filling in these gaps, and I'm gonna get some more rain gauges, and that's good. And they go, yeah, but what about our soil moisture? And it's like squirrel. We start looking over. It's like, whoa, what do you mean soil moisture? and they're adding, multiple sites, every year. They've got a team there, and we're working with the Texas Mesonet, multiple meetings a year. Hey, where do you need to go? Oh, well, we need you to go here and here. Said, can you help us? And we're trying to get more sites and more sensors out there. So Texas Mesonet, to the record, it's not Oklahoma Mesonet quality yet, but hey, this is some pretty darn good stuff. Next slide. But let's start getting into the talk of flood inundation mapping. Now, we've had flood inundation maps for a decade plus. That's, AHAPS, Advanced Hydrologic Prediction Service, flood inundation maps. And, we would find the forecast points, mile upstream, mile downstream, maybe 2 miles upstream, 2 miles downstream. And we dove in with deep engineering level analysis. Well, that's a lot of time and that's a lot of money. It gives you an idea on that right column of how much time and how much money it costs for one site. Now, just so y'all know, I forecast over 450 points across the state of Texas. And if it's going to cost, $100,000 per site, not too many people have that type of pocket change running around. But we find partners, we found state, local, Army Corps of Engineers, whoever, and we would try to come up with these AHAPS graphics, and they're on our webpage now at certain places. If you go to the next slide, you'll see that, Texas has a pretty good chunk of them, but there's, only 120, 130 across the nation, 140 across the nation. We have some in the Dallas-Fort Worth area. We have some on the Rio Grande. We have some down the, Houston area. But this is some high-level engineering, and if we have river flooding on that point, the AHAPS map might be a little out of date, but it's still some really, really good information because of the engineering that went into it. So right off the bat, let's talk about, we got this AHAPS legacy, but it was real expensive. It took over a year to make, and it's really difficult to get it added into the system. So we have that flood inundation map available. Next slide. Remember, though, that I do 450, we model over 700 sites, some of them are 1 hour sites, that type of thing. But we ramped up the national water model in Tuscaloosa, Alabama back in 2016, and it breaks it down on a smaller scale. So instead of having 700 calculated basins like what we would use, they have over 100,000 for the state of Texas. So you're talking about a much finer segment, much finer basins, guys. There are 2.7 million calculated basins across the United States. So think of that 2.7 million in the back of your head as you start thinking of computational workload and some limitations. But in the state of Texas, the national water model has the ability to get down to a lot smaller scale and a lot smaller streams than what I would be forecasting usually. Next slide. Then right off the bat, when we start talking about flood inundation mapping, I got a buddy, he's the science officer in Mobile. He goes, dude, Wally, you got to give me a talk because flood inundation mapping scares me. I said, I got you. So let's call up your AHAPS map and let's call up the National Water Model map. And everywhere that you see blue, there's going to be some type of flood inundation map, but you're going to have to explain confidence. And you're going to have to explain accuracy. He goes, I don't know any of that. I said, well, that's the beauties. We're all going to learn as we go along because the National Water Model is relatively new and the flood inundation mapping is relatively new. The point is you can see trends, which no one had before, and you can have a map. But what if there was some way that we could take our more accurate forecasts and plug it into the water model and generate a second set of flood inundation maps? So you'll have the water model with all of its parameters, and then you'll have the river forecast in our maps. And they said, we can do that. We can do an R&R. We're going to replace and route it downstream. So now the National Weather Service is like, and we've been testing this out for a couple of years. Our office is one of them, one of the prototypes. What can you give me with FIMS? We can give you an R&R and we can give you the National Water Model, and then it stops raining. We go into a drought. Still, the point is that we have that capability to give those two types of flood inundation maps. And we're spinning up a national concept now. So next slide. The point is we have viewers available so that we can grab the data. And it's, the water model calculations from theirs, the water model calculations from replace and route. FEMA's like, hey, we can give you base level engineering. We can give you all this type of stuff. But right off the bat, they said, what's the difference? Why do I need two models? I said, well, FEMA's a study. It's an engineering study. The water model uses the high resolution rapid refresh or the GFS model, not the official WPC QPF. So you're going to have a different rainfall parameter. Ours is going to use 24 hours, but it might use 48 hours of rainfall, but we're going to use the WPC forecast. And then which one are you going to want? Well, this is where it's going to have to come down to trust the scientist, which in this state is tough to do. You got to trust me to say, hey, I believe this is going to be the better of the two maps. Let's go with this. It still may not be the best map out there, and you'll have to trust me to tell you what is the best map. But the point is that they figured out a way to come up with multiple model scenarios, one all automated, one with some human influence, run it through some calculations to come up with some estimates to calculate a height, and then give a flood inundation map for a certain area. To do that, they had to come up with the hand method, which is the height above nearest drainage. That does not take into account a storm drain or sewer or something like that. But if you go to the next slide, the hand method takes the basin and says, okay, what's the lowest point in here? We're going to call that the river channel. And then we've got these elevation points up from here and there. So we know that if we're 2 elevation points up here and it's a 10 meter, we'll do this. And so it has a way to take the model, take the little basin by itself, set it all to 0, figure out what's the river channel. And then when you have a volume of water and a height of water come through with your rating curve to come up with a height calculation. 2.7 million of them across the entire United States every hour. Okay, you may say, hey, boy, there's some estimates in here. Go, there are estimates, but this allows the National Weather Service to provide a national product. Okay, now you got to trust the scientists to explain where the accuracy is and where the confidence is. The hand method allows this computation to take place. Height above nearest drainage. Next slide. So what is it we do? You know, all of the National Weather Service, including the Weather Forecast Office, has the ability to log into what's called a water viewer. This is actually the old version. The new version, you know, you can review and make notes and annotations. But if you want to, you can look at the River Forecast Center forecast, or you can look at the water model forecast, or you can actually pull up the FEMA base level engineering map to see which one is it, because you can brief on it. So next slide. Here's a case, I believe it's in the Mississippi area, where you see the FEMA map in red. The base level engineering, that's a 100-year floodplain. And then you can see our flood inundation maps, various maps, maximum inundation in blue. So if you really want to zoom in, you can zoom in on this data later and start identifying areas. What I tell everyone is, do not believe me when I say this shows a house being inundated and this one not being inundated. We are not to house level. We are not to street level, but I do feel we are to neighborhood level. The problem is that our national team that got together on this, he uses an example up in his area, up in the Northeast RFC, of a specific Domino's in a parking lot that they had during Ida, and shows it. It's like, dude, we can't get to Domino's level. We can't even get to, you know, the entire neighborhood that Domino's would deliver to level. The point is it's available. It's something better than what you had before, because you had nothing. And then trust the confidence of the scientists to explain yes or no, you know, make your decisions on it. We have FEMA maps, but FEMA maps are not storm specific. They're 100-year, you know, base level engineering. But our models, the water model or the River Forecast Center model, can add some value to that process. So the next slide. Right off the bat, though, one of our senior hydrologists goes, man, there's a lot of stuff out there, because there's also what's called a flood extent map, which is ran with the Corps of Engineers software, or a lot of times run with Corps of Engineers software. And that just tells you, there's the water going to get here, but it doesn't tell you how high, but there's a different science in there. So we have the AHEPS maps, and we have the water center maps, and we have BLE maps. And do we have a FESM map, a flood extent map? And then, you know, what about, you know, infirm? So he's like, well, let's find a way to categorize so that we know that if anytime there's a flood forecast in the state of Texas, we can zoom in and hit a point, and they'll tell us what 2, 3, 4 maps are available, and then which ones we would pick to say, yes, this is the best one. So even though there's all these jumbled up maps, we have a way of keeping track with them and have a way to explain, and we have the training to say, yes, this is a good one. This is a pretty good one. This is gold medal. This is silver medal. This is bronze level. This is an honorable mention. Okay. And that's going to be some of the difficult part as a coordination hydrologist is explaining honorable mention is the best we've got, but you can still make decisions on it. So if you go to the next slide. What I want to point out now, everyone can look at what's coming up next. Is called INFORM. Was it Interagency Flood Response Management? It's USGS, FEMA, Corps, Weather Service, and we've actually got, you know, academies, you know, University of Texas, you know, places, academics and that kind of stuff getting involved. Let's come up with a platform to get some high resolution maps on there and a place to do it, a flood decision support tool. So if you go to the next slide, besides there being a really handsome dude in that third right corner pointing to Harvey, this is the website, www.inform.us. And when you go to it, you can select FEMA 6, because it started as a FEMA 6 project, or you can go Texas. Texas is going to have more stuff in it. And if you select on it, you can zoom in to the next slide, and you can pick, you know, all the points that currently maybe the Corps, the USGS, or someone. There's an engineering firm, Eric Scheib is doing one for the, I think, Lower Colorado River Authority. I know that there's a group that's someone for the Brazos River Authority. When these maps get approved and the libraries get online, you can go here and say, hey, the River Forecast Center said 20 feet. If I click on 20 feet, what is the inundation? And you can see that there are some available up here in the Dallas-Fort Worth area, but there's a lot in the in Southeast Texas and a lot in South Central Texas as well. So next slide. If you zoom in, I actually pulled one of the sample events from, I believe this is East Fork San Jacinto, north side of Houston. When you hit 121 feet, it gets down to the various depth layers, and you can a pretty high resolution map. If it's on the uniform site, it's going to be a high confidence map, okay? Because there's a lot more engineering, a lot more science went into it. So you got the River Forecast Center forecast. If Informed Site has it, right there is some gold medal type stuff. So really, during a flood event, I will keep this up on one of my screens just at all times, so that I know that if we have a forecast out at that point, that is something I can brief at a high confident level. Next slide. But Houston seems to be the focal point of all sorts of flooding stuff. Katie went down there and said, okay, if I give all you customers, my floodation maps, and we went through scenarios and went through tabletops and that kind of stuff. And right off the bat, they said during an event, we're responding. During an event, it's too late. It's nice to have, but we really need forecast information. Okay, well, that adds a layer of uncertainty. Okay, one thing is that they don't want a paper map. They don't want a PDF given to you. They want a data server, a GIS layer. So there'll be an answer to that coming up later. They've got to say, hey, is this yesterday's data? Is this last night's data? Or is this morning's forecast? So there's got to be a way of kind of alerting them, hey, forecast updated at 8 a.m., that type of thing. Is it new or not? And then confidence. A map gives you a level of confidence that may not be there. Okay, I think this is pretty good. Hey, this has got some educated guesses in here, so give us some wiggle room. Or no, let's lock into this. I feel really strongly about that. And there isn't a real good way, and we're engaging social scientists now to try to figure out a way to add that confidence level in there. And then practice. I forgot who said it. I think it's Vince Lombardi. You don't practice till you get it right. You practice until you can't get it wrong. They want more practicing, and the main reason is it's amazing. You go into some of these places. I went to Laredo just this year, and I said, how many of y'all have ever worked a Rio Grande flood event? There were 51 people in there. 3 people raised their hand. They all work for the National Weather Service. So the entire city of Laredo, their emergency managers, their fires and stuff like that, they have not worked a flood event on the Rio Grande, and Harvey was 2017. That's how much turnover. So our training, we're going to have turnover. We're going to have constant training on these new floodation maps, because you need the practice, and then our emergency managers need it, and then the new employees need it as well. Next slide. So right off the bat, you say, hey, man, you keep talking about confidence. Well, when would be a case where you weren't confident? And here's one. We have the ability to monitor chat rooms, and all of a sudden I see the North Central RFC, their hydrologist in charge, pull that map, stop it, don't let it go out. And this was the map he's talking about. If you look in the top right screen, there's a lake there. And what happened was the water model grabbed the River Forecast Center forecast of what was going into the lake and ignored the lake and sent it downstream. The lake was able to hold it and take off a order of magnitude. Instead of 30 something thousand going down, they were only releasing 3,000. But that map showed 30,000 cubic feet per second of inundation downstream, and this went out. And the good news is it only goes out to the Weather Service for now. But the bad news is this was a glitch in the system, a glitch in the matrix, if you will, to where there was a calculation that went wrong and put out an inaccurate map. How do I explain the confidence? Please stop, don't use this. Okay. Do you have the confidence to come and ask me? And do I have the confidence to be truthful with you and say, when there's a bad product, this is a bad product? Right now, that doesn't seem to be a problem. I have no problem, calling bull. But, what happens when these come out and you don't have the human interaction? You just have someone downloading a GIS layer. And I'll be bringing that up later. But this would be a classic case of saying, hey, a map went out. This is a low confidence and no confidence map. Matter of fact, pull it and don't even use it, because it is not representative. So next slide. This is our plan. We have trained our staff. Everyone in our office has been trained on floodation mapping, how to look at it, how to find it. Okay. And we're working with our forecast offices as well. I have given this talk at El Paso, Midland, San Angelo, and you saw me give one briefly to Mobile. And then I'll be going down and giving it to Brownsville and Corpus here, since we've got a new in the new budget years. When there's flooding occurring, someone is going to be coordinating with our national center and all of our helper scientists from across the nation. And the reason I say that, when Ian hit, the Tallahassee office says, we're in the clear, we will help out. And Tampa and Melbourne, they said, okay, we'll take all the help you can get. They said, as soon as it clears, Derek from West Gulf, you're a floodation mapping expert, we want you in the house. You can't expect the local office to pull this out of their hide. When they're in severe weather ops, when they're in flash flood ops, they're already to the max limit on full-time employees. This takes 1 to 2 full-time employees to help coordinate. So we will have to team up and help. Lake Charles will have to help. Houston will have to help on these large events. You know, Amanda knows what she's doing as a service hydrologist, but what if it's a 24-hour shift? She's not working 24 hours straight. Who's going to be the next lead forecaster at Fort Worth to handle it? They're going to fall back on the flood inundation mapping team that's been put in place. Okay, right now I can produce a map anywhere in the state of Texas, and if I give you a paper copy, that means I've approved its distribution. However, by fiscal year 23, everything basically from the Brazos to the Texas-Louisiana border will be made as a GIS layer for download capabilities, and they're going to slowly roll that out, which means I don't have the ability to constrict and control the information. If there's a GIS tech-savvy individual that goes and pulls a map, they better have the confidence in the way of contacting this flood inundation mapping team to say how accurate and what's your confidence, and make decisions based on that, not just blindly pull data and say, hey, it's got the Weather Service seal, it's got to be gold standard. There are going to be strengths and weaknesses. So we've got to learn that. The team that's coming up on the plan of attack, you know, it was easy to forecast. You cannot do it with your bodies in house. You're going to have help from outside. So with that, coordinate. Well, guess who has coordinate in their title? Okay, so that's going to fall a lot on me. And then it's a continuous effort because we get new employees. We've turned over 33% of our staff in the last 3 years. Okay, so we've got to ramp them up on river forecast center operations and flood inundation mapping, and that goes along with our partners as well, their turnover employees. Next slide. So this is the plan by end of fiscal year 23. Those river basins, actually those weather forecast offices will have their river basins available, that once we have the service data layer will be available without going through the river forecast center or without being released. So that would be the water model map, and the replace and route map would be available as a GIS layer. So if you have a tech savvy group, get them in there, but then also have the way to contact what are the strengths and weaknesses of what I'm seeing. You can see that there's also a little blob up in the Northeast. They didn't want to give it all to Texas, even though we yelled loudly that we've got the most experience in it, but they will slowly spread this across the nation. Next slide. What's going to happen is the National Water Center in Tuscaloosa is going to take the lead. They said, I'm going to be the coordinator. We got 2 flood events coming on. We got one here in the South Central US. We got one on the East Coast. You got team 1, you got team 2. Okay. Start gathering your data and come back to me on your maps. Those teams will be filled from volunteers. They could be from other RFCs. They could be from the local office. They could be from regional headquarters. Everyone's been FEM trained. And what are they going to do? They're going to look at those impact statements that I mentioned earlier. You know, get with Amanda and get with Katie on. Because they're saying, hey, it says 28 feet, this bridge goes underwater, our map says 28 feet, and that bridge is no longer, which one is it? Okay, and we'll look at impact statements to try to determine the accuracy of how good that flood inundation map is. And it's an iterative process. The forecasts come out, the maps are generated, and we start coordinating. Next slide. But there's another thing that's popped up. And when an Aggie says anything good about the Longhorns, take note, okay? This year, and they've been working with it, I worked with Harry Evans, and it's called Pin to Flood. And it's using a lot of the same mapping software, but it's to give to first responders, the fire chiefs or the firefighters or the swiftwater rescue folks. We're told right off the bat, the first thing they do is they put a rock out there, they put a flag or a cone, and they go get all their gear. And if they come back and the cone's underwater, the water's rising. If the cone and water's going away, I said, hey, that'd be nice information to have. Well, now the pin to flood means you'd walk out to the water's edge, you hit your gear, you take your cell phone out, you hit it, you go back and get your gear. That pin is sent to the University of Texas in their supercomputer, and Esri will be able to get a real-time flood inundation map based on that. Okay, we've tested it out. It's tested out all across all of Texas DPS Region 6, which is the central part of the United States. And Harry's group told me that they have to, by their FEMA grant, they have to train the entire state of Texas. The Texas regions have to be done by fiscal year 23. So everyone would have the capability of at least hitting a flood inundation map. This isn't a forecast. This would be an observed. And if you have a login, you can sit there and say, hey, how well is our flood inundation map, verifying compared to this? And it also would have emergency managers to get some real time what's happening right now. So Pin to Flood is coming next year for the entire state of Texas. Next slide. The conclusions, we will be providing forecasts and we will be providing FEMs based on 2 different forecasts. Know the difference. Know the river forecast centers, because we're better. I'm not bragging, it's true. But the National Water Model can fill in the gaps in a lot of those smaller areas. There will be other FIMs available. The Corps of Engineer has a task that they have to produce a certain information. USGS may have a flooded extent mapping. So if there are other maps out there, we're going to coordinate and tell you, hey, which one do we think you should go on? It won't always be the Weather Service. I am a Weather Service spokesperson. I am not a Weather Service cheerleader. Okay. If there is a better map than the Weather Service, I will tell you there is a better map. Okay. Know the difference between flood extent and flood depth. That term sometimes gets thrown about, and if you don't, flood extent just means is it wet, yes or no. Flood depth means a lot more, because 1 foot means different than 3 feet, means different than 6 feet, which is different than 9. And I've been told that by first responders. 1 foot you walk out, 3 feet you boat out. Oh no, 1 foot you boat out, 3 feet you boat, high water vehicle out, boat out, and then one's a helicopter out at 9 feet. Okay, so flood extent mapping just says is it wet, yes or no. Multiple federal agencies are producing maps. I hope they will be as honest as I will be with the National Weather Service on accuracy and confidence. And then there is a learning curve and there's vocabulary. I may have used some words during this talk from the hydrology world that the meteorologists understand, but maybe not 100%, maybe only 90% confident on. If that's the case, let's firm up our vocabulary, because that was the biggest jump I made as a meteorologist, a hydrologist, is learning the vocabulary so we could speak. Okay, I do believe that the National Weather Service maps can get to the neighborhood level of accuracy. They cannot get to the street level and they cannot get to the house level. We're not there yet. But even a neighborhood level should tell you, hey, that neighborhood's threatened. Let's get some resources ready to go. Next slide. So with that, I'm done talking. I talk fast. This is one of the few times I stayed put around one microphone. But I do want to point out that, I love my job. So that's me. Top left, outside of Pagosa Springs, not even in my area, but you can see there's Brazos River on the bottom. There's the Guadalupe Victoria. Was it the 20-year anniversary of the '98 flood when we went down there? The bottom right would be the International Boundary Water Commission in El Paso. Anything that deals with the Rio Grande, we have to go through them, the Department of State. If you go back up, the Guadalupe River, that's the furthest upstream point of the headwater I could find in the Guadalupe River. The next one with me wearing a jacket, I told you I hate the cold, but that's one of our points outside of Taos, New Mexico. If I go back over near the monument, that's me at Redemal Dam on the border down near the, I guess you'd say the Mission area, that all the way down on the border, lower Brownsville area. I got to tour both Amistad, Falcon, and then we went down to Anzalduas and Redemal. And the Anzalduas and Redemal are the structures that if it starts flooding on the Rio Grande, how much water are we going to send down the U.S. floodways and how much water are we going to send down the Mexican floodways? And that adds gray hair real quick when those decisions have to be made, like in Alex, and it's happened a couple other times. So my contact information, greg.waller@noaa.gov. I'll answer any and all questions about flood inundation mapping. Just know we take pride in our meteorology, we take pride in our rainfall forecast, and we take pride in our river forecast. Our goal is to take pride in those flood inundation maps, the multiple ways that they are available. So with that, good to go.
Thank you, sir. We will, so we can start online to see if there's any questions here for Greg or. No, or.
Question for you.
Yes.
Is Coco Ross play into any of y'all's data?
The best way to explain Coco Ross, as I mentioned, is every hour we have 2,000, 2,500 gauges, but at the end of the day, the next day, we grab a 24-hour rainfall total. We grab all those 1 hour totals, add them all up together, and we take 24-hour gauges. That number goes to 14,000 when you count the Coco Res volunteers coming in. It does not help in the real-time quick event, but the volume calculations the next day. I give an example outside of Hallettsville once. We had estimated 4 inches of rain, and right off the bat, a Coco Res guy came in at 10.3. So we call up, and he's like, no, dude, it was 10.3, I'm telling you. So we knew right off the bat, our volume of water was half of what it needed to be. We need to double it. There are times Coco Res have really saved our bacon on the slow responding rivers, but it goes into the data set that is then downloaded later on for storm studies. It went into the NOAA Atlas 14 stuff. So the Coco Res is extremely critical, and it's an order of magnitude more data, 24-hour data compared to the hourly stuff that we get. So we think, it's Greg and Runyon, and I'm not sure who Runyon's South Central, Greg Story is North, but the Coco Res coordinators, the amount of data that they can get and the volunteers they can get is just tremendous.
Other questions here in the room, online?
I have a question.
Oh. Yeah.
Okay. So I was curious. I know that the FEM is going to be.
Oh, you went mute.
Oops.
Yeah,
There you go.
there you go.
It wasn't. Anyway. Okay. Now can you hear me?
Yes.
Okay. Awesome Mac technology. So my question is, I know that the FEM is mostly going to be geared towards emergency management, decision makers, and those kinds of folks. But do you foresee in the future doing some type of public training for what FEM is? Because the reality is eventually it's going to get into the public hands more than likely. So I didn't know if that's something that you guys thought about.
The best way to explain it, even if we did public training, that probably wouldn't be my job because I'm too large in scope, but it would probably be like a service hydrologist at a local office's job, which would be yours. As the information gets out there, there would be a public training component like a Skywarn, that would be a public, like storm, those type of things. I think that as the data comes out, we could make YouTube videos and explain it, that pretty simple, what goes into it and how to read it, that kind of stuff. It will happen because I know that talking with the USGS, they're really adamant is that they don't want it to be restricted, the flow of information to be restricted by a floodplain manager, emergency manager. Is that if it's happening at 3 o'clock in the morning and you see a forecast come out, you go and click on the website, the NFIRM website, you make your decision if you know what you're doing. So I do know that there are certain agencies that do feel that it needs to be a public education component, and that will evolve as we move and advance. I mean, they said you got to crawl before you walk, before you run. And I stood up and I said, no, we're on tummy time right now. So we're not quite crawling yet, but we're getting there. And when that happens, I bet you the local weather forecast office would have a component of training to the public.
I'm still trying to wrap my mind on how to completely spin myself up, then spin up my staff and my local emergency managers. So
the best way I can explain it is don't expect you to spin up your staff in the middle of an event.
Right.
Because you've already committed your assets to the flood fight, severe weather fight, and tornado fight. You'll have to rely on someone else reviewing and then provide that data so you can explain it. And then when it floods somewhere else, it's your turn to step up and help out the partners that helped you out before.
I worked on the Trinity River feasibility study.
Yes.
30 years ago.
Mm-hmm.
And I was curious, as your modeling has improved,
Mm-hmm.
and as development has changed a lot over the last 30 years,
Mm-hmm.
How is the level of protection maybe changed in terms of your modeling?
This is the beauty, is that one, it's not in my lane, but I am on the Trinity flood planning group. And what happened is the state legislature a couple of years ago said, we've got all these, I think, water management issues. We now want each river basin to come up with its flood planning group, similar to the water manual. And so we've been meeting, and the first year and a half, all of our meetings have been, let's identify the data that's out there so that we can identify vulnerable areas. And so it's amazing the amount of information coming in. During that process, Amanda and I were introduced that the Trinity River Authority has created their own little login website so that when the water gets high enough, you can submit a report and a picture and you can see the water inundation. So there's a new component of gathering data from the reports are out there now that the Trinity River has done. I have not been set in on the Natchez and the Rio Grande or anything like that, but I know that their project plan or whatever is out there for public comment right now, because they've got a deadline to meet the Texas state legislature. But I do know that once they start digging in, the amount of data out there, these are some old levee systems. We don't even know who they are anymore. And look at this data here. And they were gathering all this great data to come up with this regional flood planning, this flood planning group for that Trinity River. So I know that data is out there, and I know it's out there for public input because I'm a non-voting member on the team.
Gotcha.
Yeah. Yes.
So you mentioned demographics, and we deal with that at the Council of Governments quite a bit. And you're right, our forecasts are showing about 1 million people every 8 years are coming to the Hampton region. So I'm curious, do you see, especially like in the Collin County area in northern Dallas, where the population, of course, has exploded over the last decade or 20 years, Do you see a difference in flooding in the way that the landscape has been built out? And are they more flood prone than they were, let's say, 10 years ago, as those communities continue to build out?
Anecdotally, I have to give, know the difference between subjective and objective analysis. It's subjective because it's my experience. I'm seeing more rises on rivers more often now than I did when I first started 20 years ago. And I'm attributing that to there's more concrete, there's more people. I do know that, city by city, county by county, do you have mitigation efforts in place? Do you create a detention pond, a retention pond, that type of stuff? And I know that's very prevalent down in the Houston area. And I know that's somewhat prevalent in other parts of the state. The kicker is, we go through large spells where it doesn't rain. I mean, I don't want to say that, we were rivaling 2022 was rivaling 2011 because it's not fair. 2011 was brutal to start. We were converging on it. We weren't paralleling on it. So right off the bat, I know our water use was worse in 2022 than it was 2011 because, our statewide storage, we were approaching, we weren't paralleling. We are seeing those impacts. When there's farther north and east and they're building lakes, there's 2 new lakes that have been added up that's outside of my area, but 2 new lakes. We are seeing more flash flooding and we are seeing more river responses that I don't remember seeing, but I don't have these statistics number to say it's a 10% increase or it's a 5% increase. I can just say that the forecasters look and go, man, I don't remember issuing this many forecasts for McKinney or this many forecasts for, the upstream portions of the Trinity River, the East Fork or whatever like that. I do know that, when we have all these new people come in, how do you explain a Texas summer to them? And how do you explain a Texas thunderstorm to them? Because they may not know. They may not know that it is. I literally had a professor at Texas A&M say you can't get more than 4 inches of rain an hour. Okay. And I know that I've worked almost every year. I work an event that produces more than that. How do you explain the extremes of Texas? And now let's add a bigger footprint. Let's add more concrete. Let's add more rooftops. Let's add more drainage systems. We are, when the rain does come, we are seeing higher volumes, in my opinion, because I've issued forecasts that I don't remember issuing. Now, the problem that I have with Collin County, and I was nice and took it off of this slide because it calls out the former Weather Service director, is I bet you Collin County didn't care too much about floods because they've had so many hail events that have been billion-dollar hail events. I bet you every time there's a thunderstorm, they're going, whoa, 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 hail, okay? And that's recency bias, that type of thing. So my job is to say hail, and the hail's going to stop up your storm drain and it's going to flood, so I can get the flood impacts in there as well. There's always some, we're in this group, there's always a weather nerd that wants to dive into data. Okay, if the data's out there, there should be someone that wants to dive into it.
So with that, Greg, thank you very much. On the camera. So this is for you for speaking for us.
All right, thank
today.
you.
Thank you very much. So we'll go, So go ahead, we'll just take care of some chapter business real quick. First, membership dues to, get that to Stanley here. It's only $10 to be a part of the local AMS NWA chapter. Our next meeting is going to be the second Tuesday of November. I don't remember the exact date. Right now, we will have Jill Hardy from the National Weather Service Warning Decision Training Division. She'll be talking about how to train weather service forecasters. So that will be a very fun and interesting topic to dive into. For the rest of the year, the meetings will be the second Tuesday of the month. There will be 2 exceptions to that, which we the chapter officers will talk about. The first one's going to be January, because the second week of January is the AMS annual meeting. That will be held in Denver, Colorado. So if you have an opportunity to go to Denver and see 5,000 or 6,000 of your closest Met friends converge there, I would recommend it. I'll be there. And then the other one is going to be February, because February 14th is Valentine's Day, and that is also a Tuesday. So we will look at different dates for those. They will probably be the 3rd Tuesday of those months. Last but not least, something that the officers and I discussed before the season ever kicked off was talking about suggestions. If you members of the group have suggestions for speakers or topics you want to hear from for us, we will gladly take them, and we will, we will seek out those with those areas of expertise and have them speak to the group. If there is not anything else, yes, Stanley.
I want to compliment Scott and Shannon on a presentation they gave. It must have been 15, 20 years ago at an AMS meeting where you talked about the changes in demographics in the DFW area. And you talked about, all the development on up to 35 to 377 corridor and up in Collin County. And it has come true. And I just want to say, wow, you guys are right on.
Great forecasters.
Yeah, yeah.
Certainly has, no doubt.
Yes, and I want to thank you, Scott and Shannon, for hosting us this month. Of course, this is our first year back from doing all the fun COVID activities, and we're doing an alternating schedule right now with all the hybrid stuff. So next meeting is going to be at UT Arlington, and then in December we'll be back here at the Council of Government buildings. If there isn't any other business, Greg, Stan, Dave. Hearing nothing, all right. This meeting is now adjourned. We'll see you all next month.